Okay, so we have a comparison between total suspended solid and river. So river, R-I-V-E-R, only have 5 letters. So that's why the column size is small. Okay, and we want to check the measure. So this is the most important checking point for all variable. Since TSS is a number with decimal point, so we know that we need to make sure that it is present as a scale number, okay? And then river, we check our values. Okay, we check our values. We have 2 labeling here. One is actually representing Sungai Kelantan, and 2 is representing Sungai Pahang, correct? Then we press OK. And then when we check again the measure, right, scale is cannot because we have 2 categories. Ordinal for Sungai, there is no ordinal ranking for the Sungai, and this is definitely the nominal category of the data. Okay, so this is the first thing that you need to check for every set of data set that you receive. Or even when you key in your data later on for your assignment and later on your FYP, you need to make sure that you do not do any mistakes over here. Then we go to our data view. Then we scroll down to see the completeness of the data, just for a browse. To see, oh, like this, when I browse, I can roughly check, is there any missing value? So when I see I have 90 data sets, I have 90 sets of data with no missing values, I would say. But during this stage, I cannot tell whether the data is normally distributed or not. Okay, and then I also cannot tell whether my data contains any outliers. Am I correct? Right, so no outliers, I cannot tell. Whether my data is normally distributed or not, also I cannot tell. So now, when we want to proceed with the statistical analysis, before we click the Analyze button, we want to make sure that this is normally distributed. Because the syllabus only cover normally distributed data. So what are we going to do is that, okay, we are going to see whether the data is normally distributed or not. No need to press anything, you listen first. You just press Explore. Okay, now I want to see my TSS value, total suspended solid. Is it normally distributed or not? Okay, so I want to check about the plots because I want to indicate normality in terms of stem and leaf and also histogram. And also, I want to see whether my data contains any outliers or not. That's why I click the outliers. If there is any, the system will let me know. Is everyone follow? Okay. Then I just press OK to see the pattern of the output. So before I proceed, there are a few assumptions that I need to met. Okay. Number 1 is the homogeneity of the data. Number 2 is the data has to be normally distributed. Okay, have a check on this descriptive table. This one. Okay, here I have 2 things. Number 1 is the skewness. Number 2 is the kurtosis. So when I see the kurtosis is more than 0.5, I can roughly tell that my data is actually slightly skewed to the right, a little bit skewed to the right. Okay, and then when I check the histogram, this is the histogram looking. So the data is normally distributed if I see an inverted bell shape. Correct? Okay, so this is just a revision of your iuk208. And now I want to check for the outliers. So sometimes the system, I'm not sure which software or the version of the system that you are using. So here, when you see these extreme values just above the histogram, when you see these extreme values, it is actually an indicator to show that these are the top 5 values with their respective case number and these are the value. So means these top 5 is the highest TSS values. And which one is the lowest? So there are 5 data will give you the lowest TSS value. So starting from 14.2 and 14.3. Okay, so this is the way that you check for your extreme values. And then when you want to double check these extreme values, they are the potential outliers. Then you go back to the case number of 15. Then you go back to your data set number 15. Correct? 34.1. Correct? So actually the software already tells you, hey, be careful, pay precaution on these 5 top values. They might become the outliers. And also just now the minimum number, example, lowest number 1 is the case number 64. So we go to find number 64. So the value of the TSS is 14.2, correct? Okay, so this is the possible outliers because of the lowest value. Okay? Alright. And then we go back to the data set. Now, when you see the labeling, we have only 2 rivers. What is the river just now? Kelantan. Is it Kelantan? Anyone from Kelantan? Please up your hand. No one from Kelantan. Anyone from Pahang? Semua from Penang and Kedah. Okay? Right. So, Pahang versus Kelantan. Ini bukan bola sepak ini. Okay, so very straightforward. The system asks you to check for any difference, any significant difference in between this river when we want to measure the water quality index. So one of the indicator is the amount of TSS. Okay, so what are we going to do? We press analyze, isn't it? Since we have 2 groups only, we press the compare means, right? And then we choose which one? 170 test. What test? Answer from the choice. One way ANOVA? Possible? No. Not possible because one way ANOVA you should have at least 3 groups, right? So you have only one choice because you want to compare these 2 independent groups. So you press independent sample t-test. Right? So this one is your dependent variables, something that you want to measure. So this is TSS. Put into the test variable box. And then the river. So river is actually depends on your labeling. If you label 0 and 1, then you should define your groups as 0 and 1. Or if you put 4 and 5, then you need to define your group 4 and 5. Right? So we have 1 and 2 here. Good. And then for option, no need to press anything. Bootstrap is out of your syllabus. Okay? So when we see the t-test, this is the most simplest form. I believe some of you is using this when I check your chosen data set. So we have 2 sungai. Each one represents a different number of data, 41 sets of data for Kelantan and another 49 data for Pahang. So total up, sum up together, we have 90 sets of data. And you have the mean with their SD, okay? Mean with their SD. And then when we comes here, so we are always checking equal variances assumed for p-value finding. Okay, for p-value finding. So here, because of the p-value is too small, so it is indicated by the software mentioned less than 0.001. Okay, so you cannot you cannot write p equals to 000. Cannot. You have to mention p less than 0.001. Okay. And then when you report the t-test, okay, you need to mention also 95% CI, 95% confidence interval of the difference. This is the lower number, and this is the upper number. You put it in a range. Okay, you put it in a range. So our answer is yes, there is statistical significant difference in terms of the TSS value comparing 2 rivers, Kelantan and Pahang. Right? And then if you want to elaborate further, you can mention Sungai Pakam has a higher TSS value compared to Sungai Kelantan. Okay, so this is the thing. And then we go to one-way ANOA. Okay, one-way ANOA. So this is the thing that Dr. Leong covered. As usual, we check our variable. Okay, we check our variable. So we have the sales here. So see the sales, you have 2 decimal point. You know that this is maybe something 95.44. Okay, and you have how many strategy? 1, quality. Second, convenience to purchase, and number 3 is the price. Okay, so that means we want to see if you want to improve the sales, what are the factors that maybe the company staff can do as the improvement of strategy. So they put the strategy A is improve the quality, or maybe they want to look into consumer, whether they feel convenient to purchase or not. And then, of course, the price tag. Okay, higher price versus lower price. So sales is the number, so of course it's scale. And then these 3 categories are not intercorrelated. So that's why they stand as a different factor. So that's why we put nominal measure over here. It cannot be nominal. It cannot be ordinal, because there are no ranking. Okay, again, nominal, right? So when we want to check this, we press analyze, and since they are 3 groups, okay, so when you have 3 groups, you can have one-way ANOA, right? You have the sales, you put into the dependent list, okay? And then you have the strategy, you put into the factor. Okay, here, some people do it differently. It depends on what types of data that you would like to present. So, you can only show the post hoc this thing when you find some statistically significant difference. Otherwise, do not press the post hoc first, because post hoc is something to indicate significant difference. And if you want to see which group is difference, then only you press the post hoc. Option, usually we press the descriptive, okay, and then we want to map for homogeneity of the variant test, okay, right, and bootstrap. Okay, so this is the descriptive data to show. If you want to see the quality of the juice, the quality of the juice, we have in total up 60 data, 20 data sets each. For quality, the main is like this with the SD, 95% confidence interval, and their respective minimum and maximum value. And the second group is convenience to purchase. The third one is the pricing. So without looking into the tables below, we can know that the mean is highest for quality. Means to grab the consumer sales, you need to really looking into the quality of your products. So the consumer is very looking into the quality of the product. And then they don't care whether it is convenient to purchase or not. Okay? And the second one is the pricing. And then you have to see this ANOA table. So if you can see if the p-value is less than 0.05, then only you go back to the data set and press the post hoc. This is the correct way to run if you want to answer whether you need to press post hoc or not. If let's say here in the ANOA table, the p-value is very big and the f value is extremely low, there is no need for you to press the post hoc button. Okay? So since the p is less than 0.05 and the f is 4 point something, okay, then we know we can run post hoc. Then only we go back to the data set and press post hoc. One way ANOA. Okay, if you are very worried maybe you click some things, maybe you click some things wrong, or maybe you have some mistakes in the clicking, you just simply press reset. Everything goes back to the blank analysis, okay? So the sales go to the dependent and the strategy go to the factor. Now you can choose post hoc. Your syllabus always requires you to have only 5 choices. Number 1 is the LSD, second Bonferroni, number 3 is the SIDA, number 4 is the Tukey, and number 5 is the Duncan. Okay? So for your assignment, please only stick to either Bonferroni or Duncan. For your assignment, please only stick to Bonferroni and Duncan, because regression and two-way ANOVA, they met perfectly into the assumption of these two, Bonferroni or Duncan, for the assignment completion. So for here, I choose Bonferroni. Okay, just press continue. And then for this one shows that what types of data that you want to see. I want to see the descriptive. I want to see the homogeneity. Yeah. Okay, that's it. So the system will recalculate, but the difference is only on the post hoc test, which is the last table. So this last table will tell you which factor is actually significantly different with each other. So if you remember, quality is number 1. Okay, convenience is number 2, the price is number 3. So this one we see like this. Is there any significant difference in terms of the sales if we want to compare between quality and convenience? The answer is yes, because the P is less than 0.05. Okay, so if you want to see between quality and price, the answer is no, because the P value is more than 0.05. And then the last one is between quality, convenience and price. Again, this is definitely a no-no, because the P value is very big, 1.000. Okay, so this is the way that you can see. Okay, until now, everyone, I think you understand very well, because this is just a revision. Am I correct, class? Correct? Because this has been covered in your 108, and Dr. Leong already covered this one way ANOVA. Correct? Correct. Okay, I have received 7 assignments from 7 students.